In this video, I'm going to show you how to use the Pythagorean theorem to find the hypotenuse of a right triangle. The Pythagorean theorem gives us a relationship between the sides of a right triangle, which is reflected in this equation: a squared plus b squared equals c squared. This just tells us that if one of the side lengths is a and the other side length is b and the hypotenuse is c, then the square of the first side length plus the square of the second side length equals the square of the hypotenuse. So this is our master equation that we're going to be referring to throughout this lesson. Here's a concrete example in which we need to find the hypotenuse of this right triangle. So we're going to start off by stating the Pythagorean theorem for this triangle. So that just says that the side length 3 squared plus the other side length squared, so 4 squared, is equal to the hypotenuse squared, and hypotenuse is x squared. So now we've got an equation that we can solve for x here. So let's go ahead and simplify this. 3 squared is 9 plus 4 squared is 16, and that's equal to x squared. So 9 plus 16, 25 equals x squared. And we're going to solve for x, we're going to take the square root of both sides. We'll just take the positive square root because this is a length and we don't need any negatives when we deal with length. So square root of 25, that's just 5. 5 equals x. So the length of our hypotenuse in this triangle is just 5. Here's another concrete example, and this example will illustrate that our solution for x doesn't always come out to a nice integer number like it did before. So we're going to start by setting up the Pythagorean theorem for this triangle, and that's going to be just like we did before: the first side length squared, so 5 squared, plus the second side length squared, 7 squared, is equal to the hypotenuse squared, and that's x squared. And we can go ahead and compute this. 25 plus 49 equals x squared, so 74 equals x squared. And then to solve for x, we can take the square root. We just care about the positive square root because we're dealing with actual side lengths there. And we've got root 74 equals x. And this root can't be simplified at all, so we just leave it as root 74. So that's our side length. X equals root 74. In the previous examples, we've been using the Pythagorean theorem to solve for the hypotenuse of a triangle, but we can also use it to solve for one of the legs of the triangle as well. So for this triangle, if we want to solve for the side length x, which is not the hypotenuse, we can just go about our business the same as usual. We'll set up the Pythagorean theorem and then solve for x. So Pythagorean theorem, we've got side length 9 squared plus the other smaller side length x squared equals the hypotenuse squared. Hypotenuse is 10. And we can go ahead and simplify this. So this is 81 plus x squared equals 100. So then subtracting 81 from both sides, we get x squared equals 19. And then solving for x, we take the square root and we get x equals root 19. And there we have it. That's our side length. Side length x is root 19. In the future, we'll also learn how to work backwards and use the Pythagorean theorem to tell whether a triangle is acute, right, or obtuse, just based on its side lengths.